Hi, welcome to this tutorial on proving the identity that a cos theta minus b sine theta, where a and b are constants, is identical to r cos theta plus alpha, where r is a constant and it's equal to square root of a squared plus b squared, and alpha is a constant which is equal to the inverse tan of b over a. So, where do we start? Well, first of all, what I'm going to do is start with the right hand side and show you that it's identical to a cos theta minus b sine theta. So we'll start then by saying that now r cos theta plus alpha is going to be identical to, well, it's going to be identical to r multiplied by the expansion of cos theta plus alpha. And this isn't cos theta plus cos alpha. What we should know is just generally the expansion of the cosine of one angle plus another. It comes from this identity, the cosine of a plus b. These a's and b's, by the way, have got nothing to do with these a's and b's that I mentioned up here. This is a formula or an identity that you will see in most textbooks involved with trigonometry. Cosine of a plus b is identical to the cosine of a cosine of b minus the sine of a times the sine of b. So if we let the a correspond to theta and b be alpha, then using this, what we get is that this becomes cos theta times cos alpha minus sine theta sine alpha. Alright, so let's just remove this now that we've used that, and we'll just carry on. We'll expand this bracket, and so what we get is r cos theta cos alpha, and then minus r sine theta sine alpha. And if I rearrange this by putting the cosine alpha behind the r here, would have r cos alpha cos theta, and then we'll rearrange this, we'll put the sine alpha just behind the r here as r sine alpha sine theta. Why did I do this? Well, what we've got here is, because we know that r and alpha are constants, that means that r cos alpha is going to be a constant value, and r sine alpha here is also going to be a constant value. So we can say that this is identical to a constant, let's call it a, times cos theta minus another constant, r sine alpha, let's call it b, and then we've got sine theta. So can you see that I've now shown that a cos theta minus b sine theta, here we are, is identical to r cos theta plus alpha. All I've got to show now is what the values of r and alpha are. Well, that's quite easy, because all we do is we compare the coefficients of cos theta in both of these. The coefficients, the value of a corresponds to r cos alpha, and the coefficient of sine theta is this b here, and that corresponds to r sine alpha. Notice, by the way, that the minus signs, they compare with one another, so b doesn't take into account that minus. B is just r sine alpha. Okay, so what I'm going to do now is use these relationships to work out what r is and alpha. So let's just say where a, well, we'll start with b actually. We'll start with r sine alpha, doesn't really matter to be honest, but r sine alpha is going to correspond to the b, and we can see that r cos alpha corresponds to the a. So just write that in. Call these equations 1 and 2, and what we can do is divide them. If we divide them, if we say 1 divided by 2, what does it give us? Well, what we would have is r sine alpha over r cos alpha equals b over a. But if we did write that, the r's would cancel, and we've got sine alpha over cos alpha, which is better known as tan alpha. So tan alpha would equal b divided by a, b over a. So if I take the inverse tan of both sides, what I end up with is that alpha equals the inverse tan of b divided by a. And that proves this result. Now to get r, what we tend to do is we square both of these equations and add them together. So if I was to do 1 squared plus equation 2 squared, what's that going to give me? Well, if I square the first one, we have r squared sine squared alpha, and that's going to equal b squared. But I'm going to add it to 2 squared, so that's going to be to add it to r squared cos squared alpha. And so that's going to equal b squared plus a squared. Now if I pull r squared out as a common factor, we've got r squared multiplied by sine squared alpha plus cos squared alpha. And that's going to equal b squared plus a squared. But I'm going to write it as a squared plus b squared. Same thing, but it just looks nicer that way round. Now we should know that sine squared of an angle plus cos squared of the same angle always comes to 1. It's a basic identity that you should know from earlier. So if this is 1, r squared times 1 is r squared. So we've got that therefore r squared equals a squared plus b squared. And so that means if I take the square root of both sides, that r is equal to the square root then of a squared plus b squared. And there you have the value of r. r is equal to the square root of a squared plus b squared. And I also showed you that alpha was the inverse tan of b over a. Okay, so what I would encourage you to do is try and learn this identity and the values of r and alpha. And it would save you having to do all of this work. Okay, well that brings us to the end of this tutorial.